When you see this problem, your brain screams dynamic programming, but the optimal solution is actually brute force. Let me show you both approaches and how to choose the right one in interviews. You're given an array nums and must divide it into 3 contiguous subarrays. The cost of each subarray is its first element. Your task is to minimize the sum of costs. Step 1. DP-style thinking. Let's think like a beginner, or honestly, like most interview candidates. We're dividing an array into parts. That sounds like dynamic programming, right? We could define a DP state like this. DP I, k, equals minimum cost to divide the array up to index I into k subarrays. Then we try all possible previous cut positions. But notice something important. The cost of a subarray depends only on its first element. DP would track unnecessary states, recompute values we don't need, add complexity without benefit. This is a classic DP trap. Just because a problem can be solved with DP doesn't mean it should be. Step 2. Key observation. Here's the observation that kills DP completely. Only 3 numbers matter. The first element of the array, the first element of the second subarray, the first element of the third subarray. Everything else is irrelevant. So now the problem becomes: choose 2 indices I and j such that nums 0 plus nums I plus nums j is minimized. Step 3. Brute force enumeration. The array size is at most 50. So we can simply try all valid pairs of ij. This is brute force, but it's smart brute force. The function minimum cost takes a list of integers called nums. First, it stores the length of the list in n and initializes a variable ans to positive infinity. This variable will keep track of the minimum cost found. The function then uses 2 nested loops. The outer loop selects an index I starting from index 1 up to the second to last index. The inner loop selects an index j starting from I plus 1 up to the last index. For every pair of indices, I, j, it calculates the sum of 3 values. The first element of the list, nums 0, the element at index I, the element at index j. It updates ans to be the smallest value among all such sums. After checking all valid pairs, the function returns ans, which represents the minimum possible sum of nums 0 and any 2 other distinct elements from the list. Brute force time complexity O of n superscript 2. DP would be at least O of n superscript 2, but with more code and more bugs. So brute force wins. Always ask this before choosing DP. What actually affects the answer? Strong observations can eliminate DP entirely. This is how interviewers expect you to think. Understand the problem, simplify it, then choose the simplest correct approach. See you in the next problem.